We are going to execute these strictly by focusing on the logic flow. Every script starts at the absolute baseline. You open the execution environment with the $PHP tag, and you use the echo statement to output your standard text strings, like Hello World, directly to the browser window. This diagram shows the foundational arithmetic logic you need. The modulo operator isolates the exact numerical remainder of a division. By taking a user-inputted number modulo 2, you immediately route the logic to true if the remainder is 0, making it an even number, or false if there is a remainder, making it odd. You test multiple variables simultaneously using an if-else ladder. To find the maximum of 3 numbers, the execution routes through sequential checks, verifying if variable 1 is greater than variable 2, and then evaluating the remaining pathways until the true maximum is isolated. Swapping 2 variables requires parking the first piece of data. You create a third, empty variable, assign it the value of number 1, overwrite number 1 with number 2, and finally drop that parked data into number 2. Foundational PHP programming is exactly this, combining arithmetic operators with branching conditional logic to manipulate variables. Linear logic handles basic comparisons, but to process digits, we have to introduce loop mechanics. This animated diagram demonstrates the core engine of the while loop. We use modulo 10 to strip the final digit from the number, and then divide by 10 to shift the decimal over, processing the number piece by piece until nothing remains. We use this exact loop engine to solve multiple exam problems. Extracting those digits and letting them rebuild backwards solves the reverse number sum. Taking that newly reversed string and comparing it against the original input variable instantly solves the palindrome check. Finding prime numbers requires sequential factor counting. Instead of digit extraction, we use a for loop to divide the target number by an advancing sequence of integers, counting the instances where the remainder is 0. If the total count is exactly 2, the number is prime. Whether you are isolating palindromes or counting primes, the mechanism for passing these math practicals is locking down the specific constraint limits of your loops. Math logic executes internally. To make these scripts functional, we have to bridge the gap and hand data off from an HTML frontend to the PHP backend. This split-screen diagram illustrates the critical linkage point. The specific name attribute you assign inside your HTML input tag maps directly to the corresponding index inside your PHP superglobal array. Data travels across this bridge via 2 primary methods. Get routes the data directly into the browser URL, making it visible to the user. Post is required for passwords and database queries, routing the data internally as a secure payload. File uploads require highly specific syntax. Forgetting this encoding attribute guarantees failure. Your form tag must explicitly declare the entype as multipart/form data, or the server will drop the file transfer entirely. PHP operates as the translator layer, grabbing static strings from HTML form inputs and dropping them into actionable server-side data arrays. The capstone of the exam is moving away from temporary variables and making the data persistent by connecting the PHP script to a MySQL database. This diagram reveals the exact syntax sequence required to open the database bridge. The connection function requires 4 specific parameters: the host address, the username, the password, and the database name. Once the bridge is open, you can instantiate the database architecture entirely from the PHP file. Sending a string-based SQL create table command over the connection generates the table structure and the necessary columns. The college admission form proves this entire workflow. It captures form data from the post array, stores it in standard variables, and inserts that exact data by injecting them into the SQL insert into string, locking the applicant's record into the database. Executing the complete transit of data, from a user's screen, through a PHP logic evaluation, and permanently into SQL storage, is the ultimate proof of practical mastery. This modulo operator diagram finds remainders, which is the heart of the odd and even check. To find a prime number, run this test inside a loop up to your input. If the remainder is 0 only twice, it's prime. Another common test is swapping 2 variables. You cannot pour one directly into the other without overwriting data. As this animation demonstrates, you introduce a third variable, like an empty glass, to temporarily hold the first value while you move the second one over. For the math loop category, we rely on the while loop. This is simply a set of instructions that repeats a multiplication or division sequence until the initial number is reduced to 0. This handles calculating factorials or extracting digits to reverse a number. The Palindrome program builds directly on that reversing loop. You store the original input, let the while loop reverse it, and then check if the two numbers match. Every complex math program in the syllabus relies on these tools. You apply a conditional check or a repeating loop to basic arithmetic, and the result handles itself. Next is the web form category. This split screen shows how an HTML form acts exactly like a customer's order slip. It provides a clean interface for the user to type in their information and bundles that raw data into a neat package. To send data, the GET method uses a transparent sleeve, leaving it visible. POST uses a secure, opaque lockbox. On the server, PHP uses the _post variable to grab the lockbox, open it, and pull the string inputs into the processing environment. This bridge can also carry files like images, but the container needs a special label called an N-type to be packed correctly. Once an image arrives, PHP catches it in a dedicated files bucket rather than the standard post bucket to keep the server organized. Forms do not process data. They are strictly a transportation mechanism, picking up user inputs and dropping them into the PHP logic environment where the real work happens. Our final category connects PHP to MySQL. Think of MySQL as a permanent storage kitchen, housed entirely separate from your PHP processing area. This flowchart outlines the 3 strict steps required to send data over. You connect to the server, you write out the SQL instructions, and you hit execute. Step 1 uses MySQLi Connect to open the door, requiring 3 credentials: localhost, root, and a password. Then an insert into command takes the post data and assigns it permanently into specific rows and columns of your database table. Passing the heavy database questions comes down to this single workflow. You transport the data via the HTML form and hand it off using the 3-step MySQL connection sequence. When it comes time for the Viva examination, the pressure changes. Examiners rarely ask you to recite 50 lines of code from memory. They test your grasp of the basic definitions. This flashcard layout defines our tools. PHP is the server-side language that runs the logic, while MySQL is our storage kitchen, formerly known as a relational database. That just means it stores data in separate tables that are related to one another. You will likely be asked to define localhost, which simply means the server is running directly on your own computer. They will also expect you to explain that POST is used for secure data, while GET leaves data visible in the URL. Before you submit your code, check for the 2 traps that cause programs to fail. Ensure every line ends with a semicolon, and verify you are using a double equal sign to compare values, rather than a single equal sign, which assigns them. During the Viva, maintain eye contact and keep your answers strictly focused on these basic definitions. Do not overcomplicate your explanations.